All right, this is Note-Taking Guide 8.1, so the very first section of Chapter 8. And we're going to talk about the concept of similarity, meaning are two figures similar to each other? And if they are, how are we going to tell? So I've already talked about the fact that in order for them to be similar, they have to have the same angle measurements. And then we decided from the bell work today that they have to have a scale factor for their similarity on sides, meaning the same number would have to be multiplied by the one side to get to its corresponding side on the other shape. So here's the point to be made. We would be comparing similar sides. So this angle is marked with 1 marking and this angle is marked with 3 markings. So we know that the similar side would be marked with those same markings over here. So how does 7 compare to 14? How did we get from 7 to 14? We multiplied by what? 2. So we're thinking that the scale factor would be 2. If these triangles are similar, then that same scale factor will happen for every side. So this side is 10. Is its corresponding side have a scale factor of 2? Did I multiply by 2 to get from 10 to 20? Yeah. And did I multiply by 2 to get from 6 to 12? Yeah, I did. So because that happened, these two shapes are similar. Their sides are actually what we call proportional, meaning they reduce to the same number. They would reduce to 2 because 20 over 10 would be 2, 12 over 6 would be 2, and 14 over 7 would be 2. So the scale factor on that is 2. So when we're looking for similar triangles, we're looking to see if they have the same angles and if they have proportional sides. So let's take a look at this first triangle right here and decide, first of all, which triangle we think would be similar to HGF. Now, if you remember when we talked about this, we have to do it in the same order. So I'm going to go mark my angles that are congruent. I know that this angle right here is congruent to this angle right here. Does anybody remember the rule why those are congruent? Yeah, they're vertical angles. So I can mark them congruent to each other because they're vertical angles and vertical angles are congruent. Okay, does anybody know for sure about another angle that's congruent? How about 61's equal to 61? Can we mark them congruent to each other? We can. Now, does that automatically make the third angle congruent to the third angle? It does, right? Because if you take whatever this angle is away and that angle away from 180, this angle and that angle would still have to be the same because we'd take the same amount away from 180. So we're marking this with 3 markings. So now that our angles are marked congruent, it's really easy to see which order we need to write our letters in for our other triangle. So this triangle was HGF. So 1, 2, 3 on my marks. So on the other triangle, I have to go in that same order. 1, 2, 3. So which triangle is similar? Yep, HTS. Because you have to do it in the right order. So triangle HTS. Okay. Questions on how I did that? So this is just the similarity statement where you're going to state which triangle is congruent. But again, in order to state which triangle is congruent or similar, I guess in this case, you have to go by congruent angles in the same order. Okay. Here's a second set of triangles here. And again, I just want you to write me a congruent statement here. So we know that these are already similar. So here's 76. I'm going to mark it with 1 marking and it's congruent to 76. Okay. Because I was already told that these are similar, which angle would I mark the same as angle H in the other triangle? Which one's the same? Would it be W or V? It's W. Okay. And then the last angles would be marked congruent because they're also in the same position in the triangles. So after I mark my angles congruent, it's very easy to see which order I need to write my stuff in. So I go F, G, H. So 1, 3, 2 on my angle markings. So which triangle is similar to that? You have to say in the right order. It's going to be UVW. Good. UVW. So mark your angles congruent before you write your similarity statement. You guys following me on that? Okay. So now this time it says triangle ABC is similar to triangle DEF. Find angles D, C, and E and find the length of side C. So let's mark our triangle. Do you guys remember that I said in the same order tells you what's congruent to each other? So angle A is congruent to which angle? D. So angle A is right here. And angle D is right here. They get the same marking in them. They're congruent. Okay, what other angles get to be congruent? B with E. So mark B with 2 markings, and let's go mark E with 2 markings, because if we mark them the same, we know they're congruent. And then the last one on our similarity statement says C is congruent to F. So angle C I'm going to do with 3 markings. And angle F is going to be marked with 3 markings. Now that we have them marked, some of the angles have measurements in them. And if they have measurements in them, we can mark it on the other triangle. So do you see how this angle marked with 1 marking right here is 30? If it's 30, what does angle D have to be? 30, because they're congruent to each other from our similarity statement. If angle F right here is 110, what's angle C going to be? 110. And if angle B is 40, what's angle E going to be? 40. So we actually found all of our answers. The measure of angle C equals 110. The measure of angle D equals 30. And then the last one, the measure of angle E equals 40. Just from marking our triangles similar and using our similarity rules to know that our angles are congruent. Then the last thing it says is to find the length of side C. Okay? In order to find the length of side C, I have to figure out how I get from one side to the other. So what did I multiply 5.9 by to get to 11.8? Does anybody know? If you don't know, there's a really easy way to figure it out. Take the big number, the 11.8, and divide it by the little number, which is 5.9. And tell me what that comes out to be. Shout it out at me when you have it. It's 2, right? So we think our scale factor is 2. We actually know our scale factor is 2 because they already told us that our triangles are similar. So if we multiplied 5.9 by 2 to get to 11.8, what am I going to multiply 11 by to get to this other angle? I'm going to multiply it by 2. So this angle over here is going to be 11 times 2, which is how much? 22. Okay, so again, what I did was I figured out the scale factor from one triangle to the other. I can always find my scale factor from taking one side and dividing it by the same side on the similar triangle. That will give you your scale factor. Questions on how I did that? All right, last example then here. Says find the height of the tree using similar triangles and scale factors. So we're going to find the height of the tree. Tell me this right here. What kind of angle is that?
90 degrees.
Yeah, and that's the same as this angle over here, right? 90-degree angle. So on this triangle, this big triangle and the little triangle, so these are the two triangles I'm comparing. Let me just kind of highlight them so you can see them. The big triangle's here in green, and the little triangle is the one that we're comparing to it, which is here in orange. So we already know that they both have 90-degree angles here. They're marked congruent because we marked them both 90. But look at this. Isn't that the same triangle or the same angle in both triangles? So that one's congruent to itself no matter what, right? Which automatically makes this one congruent to that one, because if two angles in a triangle are congruent, the third one automatically has to be congruent. Okay? So then what I'm going to see is if I can find a scale factor to be able to help me get from the length of this side to the length of that side. So how did I get from this little side right here that measures 3 to the length of the big side of the triangle, so the same side of the big triangle that measures 30? What did I multiply 3 by to get to 30? 10. So if I multiplied by 10, my scale factor is 10. And what would I have to multiply 2 by to get to the height of the tree? I would have to multiply it by 10. So what's the height of the tree? 20 meters, because 2 times 10 is 20. So again, just to recap, in order to figure out missing sides of a triangle that is similar to another triangle, you have to find the scale factor. The scale factor comes from finding what you multiplied one number by to get to the other number. In this case, it was 10.